Hi everyone, this video is for Lab 6, the last lab. Looking back the lab in the past, we'll learn how to compare mean differences in dependent variable by independent variables and plan the contrast using ANOVA. We also briefly learned what a correlation is and how to interpret it. Today, we will expand correlations into correlational analysis, such as regressions. One of the common correlational analysis is regression analysis. In this lab, we will talk about how to conduct a linear regression analysis using a single predictor and multiple predictors. Specifically, we will begin to okay, before talking about the object, please make sure that we need these materials. As usual, you need a lab assignment sheet 6 and the data. In this lab, we will use the same data that we used in lab 5 and two-way instruction. And same as in the past labs, I will use two-way instruction demo data in this lab for a demonstration purpose. Also, before jumping into the lab questions, please look at Duckworth and Seligman's article, and they use a regression in that paper and then present um, the results in the standard way. I already highlighted the part regarding how the authors presented the result of multiple regression analysis in their study. And they actually tested whether multiple predictors could predict academic performance dependent variable in this study. So please take a look at those, especially the abstract and the um, result section, especially the tables. So let's move to the object. Let's talk about the object. Specifically, we will begin with to draw plots to see any overall trend in our data. Then, same as in ANOVA, we should also make sure our data met a couple of assumptions of a regression analysis. So we're gonna look at that and do a plot, and then once the assumptions was met in our data, then we will do a linear regression analysis using both one predictors and multiple predictors. If we use a one predictors, we will call it a simple linear regression. And if we use a multiple predictors, and then we will call it multiple regression analysis. But one thing that we remember is always there is a one single outcomes, right? Okay. Then um, the basic concepts are the basic concepts are almost the same across the simple linear regression and multiple linear regressions. The only difference is the number of predictors. Once you fit the model, you may want to know whether your model is good enough. So we're going to talk about the model fit, goodness of fit, such as R squared, and then specifically we're going to cover adjusted R squared because the R square is a Bayesian as we talked before. And um, then we will talk about the individual cases. In some situations, you may want to know if there are any cases which behave in an not in a non-expected manners by our model, which is usually labeled outliers. There's some ways, two or three more ways to detect outliers. So we're going to talk about that, and you may want to take them out or handle them in some ways once we detect there is some outliers. So we will look at to detect or identify probable outliers using box plot, standard residuals, and Cook's distance. Actually, these two, we're going to briefly talk about these two and then actually check this one. And then once you think your model fit well, and then that means that the primary estimates are trustworthy to be interpreted. First, we're good to go to interpret what the parameters means, and then so we talk about the how to interpret the parameter estimates. I meant both unstandardized and standardized regression coefficients. We're going to talk about that later in depth. Then we want to conclude based on the findings. We usually want to talk something about a larger population rather than just a sample that I analyze in my data, which is called generalizability. In order to achieve generalizability, we also need to make sure that our data met the required assumptions. So we will check those assumptions again for the generalizability. Same as usual, we will describe and present all these findings in APA style. So this assignment is due by November 20th. Yes, I know. This is in the middle of holidays. Yeah. So but still, I'm gonna set the date as usual, not to confuse you. So this assignment is due by November 29th, Sunday midnight. Hope you have enough time to complete and understand what we are doing in this lab by then. Actually, it is way much better if you finish this before the holiday. And I really wish you finished this before then and enjoy the Thanksgiving without even remembering any of this regarding this lab.